Hello everyone, welcome back. This is Mr. Sen Masapi, and in this video we'll be looking at logarithmic differentiation. Basically, this is just log differentiation. Alright, so now what do you have to do? Or when can you apply this to say? Okay, so if you have, say, a function y being equal to some function which is g of x, the same particular function is raised to another function h of x. Then you can apply what? Log differentiation. Basically just two steps you have to follow. Okay, so step one, introduce logs. The moment you introduce logs, all you will have is in y being equal to what? In g of x to the what? H of x. Now basically we know that according to logs, the power can drop. So you have in y being equal to h of x times in g of what? X. And you have this standard. Then step two, all you have to do is to apply what? Implicit differentiation. Apply implicit differentiation. Okay, so that case. So this is basically everything you have to do. Alright, so the only way we understand this is with a few examples. So to say examples, I only give 3 examples for this video. Okay, so suppose we've been told to say find dy over dx, and then question 1 is y being equal to x to the x. So you're having y as a function being equal to a function x being raised to another function x. So let's just follow the steps. Step 1, introduce logs. So I have in y being equal to what? In x to the x. Then this will just be in y, which is the power, and I have x in what? X. Then I can just do up the data and differentiate implicitly left and right. Now, whenever you're differentiating using an implicit way, remember, differentiate each term with respect to x. But the moment you differentiate a y term, remember to add dy over dx. So I'll start with my left-hand side because it's basically simple to differentiate the left-hand side. So just let my left-hand side be equal to some variable that is not common with the variables I'm having in my situation. So I'll say, okay, let the left-hand side be called q and let it be equal to in y. Then all I have to do is just differentiate q. Now, whenever you have in something, it's always 1 over something times the derivative of that particular something. Now, if you differentiate y, you get a 1. But remember, implicitly, if you differentiate y, you get dy over dx attached to your differential. So you have dy over what? Dx. To be precise, for the sake of explanation, I'll put the 1. Now, forward it up, or let me just say simplified, you just get dy over what? Dx over what? Y. And that's the value of what? Q prime. Then we can go to our right-hand side. The right-hand side, all we have to do is to let the right-hand side equal to some value other than what we have. So I'll say let p equal to what? X in what? X. Okay, so if you look at this, x in x is like having a function p being equal to some other function being multiplied again by another function. So you basically have the product rule. So all you have to do is say p prime is equal to what? A prime b plus what? B prime a. Then do out the data. Look for a. A is going to be x. What is a prime? So b basically 1. What is b? B is in x. What is b prime? 1 over something times the root of something. Here we'll have a 1. So b prime is basically just 1 over x. But put this back here. I have b prime being equal to a prime 1. B is in x plus b prime is 1 over x times a is x. So I have p prime being equal to in x plus x over x. So p prime is equal to in x plus 1. So I have this. Okay, so now remember the left is this guy here. dy over dx is over y. So all I have to do is just let the left-hand side be equal to what? The right-hand side. So left-hand side was q prime. The right-hand side is p prime. Q prime, is dy over what? Dx over y. P prime is simply in x plus 1. We can just cross multiply this, and if we do that, we'll get dy over what? Dx being equal to y times in x plus 1. Now, if you can recall, the value of y is simply x to the x. So you just get the value of y and plug it for y. Therefore, dy over dx is equal to the value of y, which is x to the x, times in x plus 1. And this is your derivative. All right, so that's how you go about solving a question involving what? Logs. Okay, so let's look at another example, which should be a bit interesting on this one. So suppose you have y being equal to what? X to the sine x. Okay, you can always pause the video and attempt to do this question on your own, then relate with what I would do. You can walk with me. Remember, step 1, introduce logs. So you get in y being equal to in x to the sine x. So after that, we can drop the power on the right hand side, and we'll have in y being equal to sine x in x. Then we can just do up a data and look for the right hand side and the left hand side. So start with the left. So we'll let the left be equal to q. So let q be equal to what? In y. So this q prime. Q prime is basically just 1 over y times dy over what? Dx. So like q prime will be dy over dx over what? Y. So we have this guy here for q. All we have to do now is to look for the right hand side. So for the right hand side, all we have to do is to let it equal to some variable that is not really common with what we have there. So we say p. So let p equal to what? Sine x in what? X. You know, it's the function, so it's another function. A function multiplying another function, power. So I have p prime being equal to a prime b plus b prime a. To do up some data, you will know that a is equal to what? Sine x. So a prime is equal to, derivative of sine is cos. So I have cos x. What is b? B is simply in x. What is b prime? It's 1 over x times derivative of x, which would be 1. So just get that. So p prime is equal to a prime, which is cos x. B, which is in x, plus b prime, which is 1 over x, plus a, which is sine what? X. Okay, so this would just be like p prime is equal to like cos x in x plus sine x over what? X. So you have that there. Okay, so I'll just take this to another part, and so you have p prime being equal to what? So p prime, if you can recall from what we have, is simply just cos x in x plus sine x over what? X. Then q prime is just dy over dx over what? Y. So I'll say left equal to the right. So q prime is equal to what? P prime. So q prime is dy over dx over y being equal to p prime, which is cos x in x plus sine x over what? X. Do some cross multiplication. You get dy over dx being equal to what? Y times what you have here as cos x in x plus sine x over what? X. Now basically we need to substitute for y. So dy over dx is equal to the value of y. Remember, the value of y is simply x sine x. So you have x raised to the sine x times everything that you have here, which will be cos x in x plus sine x over x. So this is the derivative. This is our final answer, the answer we were looking for initially. Let's look at the last example now. So suppose you have a function y being equal to sine x to e to the something again, such as 2x plus 1. Right, properly. Say you have 2x plus what? 1. So you can pause the video and attempt to do this question on your own. So first step is to introduce logs. So you have in y being equal to what? In of sine x to the what? E to the 2x, e to the 2x plus 1. After that, you know that it will drop, and you will get e to the 2x plus 1 times in of sine x. Alright, so all we have to do now is to do some basics. So for the left hand side, you know, we end up having dy over dx over y, sorry. For the right hand side, so one more we have to introduce the product rule. So just let p equal to what? E to the 2x plus 1 times in sine x. So, so we know that P prime will be A prime B plus B prime A. So A is E to the 2x plus 1. The derivative of E to the something is always the derivative of something times E to the something. I don't really have to show you a data of how to differentiate 2x plus 1 because you can just apply power over there, so you get a 2. So I have 2e to the 2x plus 1. Then for b, you know b is in sine x. So you just say b prime is simply just 1 over something, which is sine x, times the derivative of sine is simply cos x. Now one thing you should know is this: tan x, let me say tan theta, is equal to sine theta over what? Cos theta. Then we have cot theta. Cot theta is equal to cos theta over what? Sine theta. Now, since we end up having cos x over sine x, this just implies that b prime will be cot x. Then we can basically just put p prime, the value of p prime there. And this will just be dy over dx over y being equal to the value of p prime. If you substitute in the p prime expression of a prime b plus b prime a, you know for sure you end up having something like 2e to the what? 2x plus 1. Then you get in x. Sorry, it shouldn't be in x. It should be in sine x. Yep, in sine x plus you get a cot, like we said, for b prime. Then you get e to the 2x plus 1. Yeah. So after that, you can just cross multiply because it's going to be over 1. And you have dy over dx being equal to y times the root of this 2e to the 2x plus 1 times in sine x plus cot x times e to the 2x plus 1. Then substitute for y, dy over dx. Remember, the value of y was sine x to the e raised to 2x plus 1. And this is multiplied by 2, e to the 2x plus 1 times in sine x plus cot x times e to the 2x plus 1. So this is your final answer. Alright, so to get a hang of this, all you have to do is just practice the examples over and over again, and you get a hang of it. Alright, thanks for watching. My name is Mr. Hussein Masapi. If you have questions, you can reach me on WhatsApp on that number or the number I'll put in my description. Alright, don't forget to like and subscribe, and remember to strategize before you become a statistic. And let's try and push for that A+.